Okay, herewith I'll show you that absolute value, the 2023 combined maths, absolute value or modulus of a real number. Modulus of a real number. The actual pure maths mathematical term we call absolute value, but frequently using modulus, mod symbol, mod. That is like this, a bracket come like this, it's called modulus, right? 5, modulus 5, or any like that. So we'll see what you mean this modulus, the big exam question, structured part. We have modulus equation to draw graphs, solving inequality, and essay problem we have some modulus trigonometric equation, integration, we have some modulus parts. Okay, so basically here you can see, you can learn what you mean this modulus and what the definition and what are the terms that we use frequently. Okay, write the heading and you can write below. I'll give us some definition, defining of the modulus. So write below, modulus of x, modulus of x, modulus of x. Modulus of x, small letter x, is denoted by, write this symbol. This we read here after mapanka, singaling kina mapanka, modulus of a number. Okay, modulus of x denoted by this. So if modulus 5, modulus 7, modulus -7, modulus. Okay, in complex numbers, vectors, the future will use this modulus symbol. Okay, now I give you what you mean this modulus and its definition, right? So write below, next write this definition of modulus x, definition of modulus x. See what the meaning of the modulus and its definition. That's important, right? Actually, modulus mean a completely a positive number, right? Modulus become a clearly plus value. See what the definition is, what the meaning of this symbol. Now I am going to show that one, right? See that modulus x is equal to x. Also, modulus x is equal to minus x. So what is mod x equal to x or mod x equal to minus x? See what you mean that? Mod x equal to x, when we use that, there's a condition, right? If x greater or equal 0, inside the modulus symbol, if it's perfectly positive that you know already, then you can say the same as this. X is positive greater than 0 or equal to 0. Or otherwise, second condition, modulus x can be shown as minus x when it's happened if x less than 0. If x is negative inside the mod symbol, it's also like a bracket pattern. Inside that symbol, if you see the minus number, you put extra minus, additional minus, and show that. Okay, right, copy this. This is the definition of the modulus, either completely positive or something like this become a negative, right? Minus x. I'll show example. Modulus 7. It is positive, stride is positive, therefore that is 7. Modulus minus 7. So what do you mean modulus minus 7? Inside the modulus negative symbol. So x is negative therefore. Then you write additional minus, extra minus, and say what inside that one. Minus 7. You know, minus, finally plus 7. Examples, next one. Modulus 100. That is 100 because it's slightly inside positive, right? See another example, a minus 5 or 50 modulus inside minus symbol. Then we write according to the property or the law of the definition of the modulus. You write a minus and what inside, write that. So the answer 50 plus 50. Another example. Modulus how? Whatever number, can be fraction, decimal, integer, whatever. So here what the answer? We write a minus because inside minus. Here what is x is minus half. Minus x. X is minus half. So therefore plus half. So very clear this example according to the definition. What is modulus of a number mean? It's exactly a positive number. It's always a real positive value, right? All the modulus value become positive. See example, 7, whatever inside, finally it become positive, right? It's the examples of this modulus. Then you can write a note below. Therefore, modulus of a value is always a positive. Modulus of a value is always a positive. Always positive, right? Modulus of a real number is always positive, right? So we have modulus equation to solve, modulus inequal to solve, modulus graphs to draw, right? Next time we show some couple of graphs how to draw the modulus functions. You will learn your primary class how to draw straight line graphs, parabolic graphs. I'll show modulus graphs. Right, next heading. Graphs of the modulus functions. Graphs of the modulus functions. Graphs of the modulus functions. Okay, so see one graph. I'll take a graph to show modulus function. First one, y equal modulus x. Y equal modulus x. Let's see how to draw. So if they ask no modulus symbol, that's your primary, I think grade 9 mathematics. Y equal x, you know, y equal mx. Straight line through the origin, right? So here y equal modulus x. See how to draw this graph and what are the properties. So always when you deal with the modulus problems or any modulus equations, use the properties, use the definition of the modulus, right? So therefore, what the modulus property? If x greater or equals 0. If x greater or equals 0, y equal, inside positive the same. Y equal x. If inside positive more than 0 mean positive, then show as it is. But the other definition, if x less than 0, that means negative, less than 0 means minus side, right? So what is y equal? You write extra minus and write what is inside. That's all. Therefore, see, y equal, I said graphs of modulus functions. Number 1, right? Number 1, y equal mod x, the basic graphs. From that we have to improve, extend some other pattern. X is 0 or more than 0, y equal x, okay? X negative less than side, y equal minus, write this definition. Therefore, the graph has two portions, your primary class equations, y equal x. I hope you can draw this. Y equal minus x. The two graph both should pass us to the origin, right? Okay, now see the graph. X-axis, y-axis, origin. X is 1, 2, 3. Here say minus 1, here positive 2, above the x-axis 3, here minus 1, minus 2, and minus 3. Left hand side here minus 1 x values. Okay. So see how to draw the y equal x, your primary mathematics. X1, y1, x2, y2, x3, y3, x0, y0. Here you will find the more than 0 parts on every modulus has 2 regions, more than 0, less than 0, or any like that. So more than 0 part only. Therefore the graph is like this. This is the graph y equal x, right? Y equal x. Now see, less than 0, x is negative, minus sides. The graph is y equal minus x, y equal minus x. So what is x equal minus 1? What is if x equal minus 1? Minus minus 1 plus 1 here. What is x equal minus 2? Minus minus 2 plus 2 here. Say minus 3 means here. Therefore, this is the other portion of the graph, right? So actually what happened, if there is no modular symbol, the graph should be produced like this. It's go like that. But if the mod comes, no below the x-axis, completely up, there's a reflection. Like a x-axis is a mirror image. X is a mirror, is the image, right? So it's the completely part, the both of this. This is called y equal minus x part. This is y equal x. Together the graph of what? Y equal modulus x, right? This is the graph as number 1, y equal mod x graph, simple. Using the definition and the sketch, right? So next I will show you another example, right? Number 2, y equal 2 times mod x, like that. Y equal 2 times mod x. So start to draw. So to draw before the diagram, before the graph, you have to complete by using the definition, how the shape of the graph, how the straight line becomes. It's all a straight line graph, right? So always follow the definition. If x greater or equals 0, that means complete absolute positive side, right? So therefore the y becomes, outside 2 is outside, right? 2 inside completely positive condition, therefore no change as it is, right? So y equal to x, simple grade 9 mathematics straight line graph, right? Next comes the other condition. If x less than 0, by definition x becomes negative. If x becomes negative, how the modulus says, you put extra minus and write what is inside the modulus symbol, right? Therefore here what? Y equal, there's a 2, that x you write, put extra minus and what is inside. So what do you mean that? Multiple here, multiple, so minus 2x. So the 2 portion, always a modular sketch as 2 possible, two portion, positive side and other side maybe, right? 2 parts of the graphs. So therefore simple, you can draw that graph. One is y equal 2x, other one is y equal minus 2x, by using your primary properties, how to draw straight line graphs, right? So in advanced mathematics, we won't use a big graph sheet and all. Simple diagram, but the points are important, where the graph cuts the axis. So here x1, here x2, if I mark the 3 also, here minus 1, minus 2, and here minus 3, and here what? 1, 2, 3, 4, 5, 6 here, and minus 1, minus 2, and so on, right? So see the first part, x is more than 0 side, y equal to x, y equal to x graph. How to draw that? How to draw that one? If x is 0, y is 0. If x is 1, y is 2. If x is 2, y is 4. If x is 3, y is 6, right? A straight line through the origin. Straight line through the origin. When you draw the y equal to x graph, positive side. Now x less than negative side, x is less than side, y become minus 2x. So that if you put x4 minus 1, x4 minus 1, minus 2 multiple minus 1 plus 2. If x is minus 2, minus 2 multiple minus 2 plus 4, minus 3 plus 6, right? If you brought the same, see the like the previous question, same method, right? One is, if actually there's no modulus symbol, the graphs goes like this, but here no graph shown below. It's a reflection, right? This for y equal to x, this for y equal minus 2x, the combined graph for that given 2 times modulus x, right? So very clear. This is my second diagram, second question. I hope you understood this modulus. It's the beginning of this inequality of the solving modulus. Should draw many graph like this, parabolic also we have in the modulus symbol. Okay, I show next another graph. Right, number 3. Draw the graph of y equal x minus 1 modulus. Y equal x minus 1 modulus. So see, same method. Use the properties of the definition. Follow the definition. Then only it's clear, right? Always follow the modulus definition. Then it's very clear. Otherwise sometimes wrong, become wrong answer, error. So inside this, x minus 1. So x minus 1 is greater than 0 or less than 0 we have to consider, right? So first one, if x minus 1 greater or equal 0. What is inside the modulus? Take as more than 0 or equal to 0. Or in the other word, or that is, what is x answer? Greater or equal 1. X is greater or equal 1. So under this condition, how the modulus y equal, inside positive, inside completely a positive, then show as it is. No changes. That's the modulus property definition, right? Show as it is. Next one, if x minus 1 inside the modulus less than 0. What do you mean less than 0? As the negative. Or otherwise x less than 1. That means under x less than 1, but the definition says y equal, you put extra minus and write what is x4, what is inside the modulus. Therefore, the equation become how? Y equal minus x plus 1. So, see, two portion, always two graphs there. Two graphs available, okay, two graphs available. I hope you can draw this graph by using your knowledges. But here we won't prepare a big table method like O levels. So, the method important to draw the graphs, straight line graph, intersection points are important. Where the graph cut the x-axis and y-axis, right? So, first one to draw. Put x for 0. If x is 0, find what is y. If x is 0, y is minus 1. Okay. If y is 0, what is x value? Put y for 0, x is 1. That's enough to draw the first graph. Put x for 0, find the y value. If put a y for 0, find the x value. See the second graph, y equal minus x plus 1. Follow same method. If x is 0, what is y answer? 1. Y is 1, right? If y is 0, x equal 1. Okay. Now we can draw these two sketch in one coordinate plan. So they are like oral mathematics, only the definition of the modulus important. Hereafter you are drawing your method of straight line graphs. So how that? Here x-axis, y-axis, origin. Show x is 1, negative side minus 1. Here 1, 2, 3, 4, below same as, you can show a few values, right? Show a few numbers, enough. So first you have the condition here, x is more than 1. Here x is 1, more than 1 only our graph, more than 1. So what the first graph? x0, y minus 1, x0, y-axis minus 1, y0, x1. You know, to draw a straight line, minimum 2 points enough. Maximum any number of points, 2 points enough, right? And if we draw, is the straight line y equal x minus 1. But here this is wrong. Why wrong? Our condition, more than 1, greater than 1 part only. From 1, more than 1. So it can go like that. Therefore, we won't take less than 1 portion, right? This won't come. But the first time you can show some dot line and decide you can't take this part, right? Only that side. Next, say next graph portion, x0, y1, x0, y1, y0, x1. These 2 points, right? So what happened actually, there's a below portion reflected, right? So these two are the answers. This is for what? Y equal x minus 1. But this is for the what? Y equal minus x plus 1. Altogether, the graph of what? X minus 1 modulus, right? That's the graph of that one. I hope you clear this problem, right? These graphs. Graphs of the modulus functions. Okay, I show another graph, number 4. Fourth one. Fourth graph, y equal 2x plus 1 modulus. See, start the work, draw this, mute the video, stop the video and to try that and check with my video. Y equal 2x plus 1. So always follow the modulus definition. 1 for positive, what happened? And if it's negative, what happened? That's the modulus definition, right? So what is inside? If 2x plus 1 greater or equal 0. 2x plus 1 greater or equal 0. Or otherwise, another word, you can say what? X is what then? X is what? Minus half. So x is greater than minus half or equal to minus half. How that? Y equal inside perfectly positive then. Then you can write the same as it is, right? It's the one graph. Y equal 2x plus 1. No any changes. Second definition, if, what is that? Second definition, 2x plus 1 less than 0. Less than 0. Or otherwise, x less than minus half, right? X less than minus half. That means inside the modulus minus. then we put extra minus and write as it is. So y equal minus 2x plus 1, okay? Or otherwise what it is, y equal minus 2x minus 1. This is your second graph. Then hereafter your simple O-level knowledge to draw the straight line graphs and complete the answer. Check with your solution if you work your own knowledge how the graphs. So always follow the modulus properties, then it become simple, right? So to draw the straight line, you can find a couple of points. Y equal 2x plus 1. If x is 0, if x equals 0, what is y value? Y is 1, okay? x0, y1. Next, if y is 0, if y is 0, how the x answer? Minus half, right? To draw this graph, the two parts enough, the intersection points of the respective x's. Next, see the other one, to draw y equal minus 2x minus 1. Same method, find the 2 points where the x and y becomes 0. If x is 0, what is y answer for this graph? x0, y minus 1. If y is 0, what is that? X equal minus half, right? That's all, 2 points enough. Now prepare a nice coordinate axis and draw the sketch. Is the method how to draw. So in my tube, you can see there are nearly 50 problems in modulus inequalities and drawing graphs. You can work all these MyTude questions. Also, I'll explain next lesson parabolic modulus is how. Okay, now x-axis, y-axis, origin. Here 1, here minus 1, y here 1. The main points enough, right? You need the half, minus half, ne? This is the minus half, right? Our part is more than minus half, how the behavior of the graph, and less than minus half is how. So this is minus half. So the first one, x greater or equal minus half. This is the graph and how that. x0, y1, x0, y1, y0, x minus half. See like this. So you won't take down because more than minus half only this condition to draw y equal mx plus c pattern. Now see the other portion less than that side behind the minus half. How that? x0, y minus 1. x0, y minus 1. y0, x is minus half. This one. So it become like this. But I told as the earlier graph. We say more than minus half and less than minus half part only. Therefore, the below if you that's wrong, right? This part is wrong. Only the above the x-axis is the graph, right? That means actually it comes, that's a reflect, it goes up. This is the reflect of that. It goes up, okay? This is the graph y equal 2x plus 1. And here this is the graph y equal minus 2x minus 1. Both together combined we call modulus graph, right? This is my fourth question, modulus function. But it's all a linear function, straight line graph using modulus symbol. Okay, see another one. Number 5. Y equal x plus modulus x. See how? We have so many various types of equation modulus. Whatever, no problem. If you follow the modulus rules or definition, then simply you can sketch. See, can you how that x plus mod x. So follow the modulus properties. But remember one thing, the modulus for the only this we have the rules. This is your ordinary x value, right? No rules for that part. Follow the modulus part only, you have the definition. So under the condition, first you take inside the x only. If x greater or equal 0, right? If x greater or equal 0, y equal, this is okay, positive. Inside the main part, inside x 0 or more. Therefore, that is same as it is, no changes, same as it is, right? So, what the answer? Y equal 2x. This is one of the graph, y equal 2x, right? Next comes the other condition. If x less than 0, if x less than 0, negative side, how that? Y equal, here first one x plus, inside minus mean, you put extra minus and write as it is, okay? So but the answer therefore clear, y equal 0. So see two portion, one equal y 2x, other one is y equal 0. Draw the both in one sketch. So how that now? Prepare a proper coordinate plan. X-axis and here y 0. Okay, so x is more than 0 on your part. Here 1, 2, here 1, 2, 3, 4, and show a couple of here minus 1, below minus 1. So complete the first one, simple, y equal mx pattern. What is y equal 2x mean? x0, y0, x1, y2, x2, y4, right? That's the portion more than 0, x greater than 0 part, right? Next one, negative side, x less than 0, graph is y equal 0. What is y equal 0? No x values. Y equal 0 mean x-axis, okay, x-axis. Therefore, this is the part. See, first time you are learning was the 2023 levels, like this graph along the x-axis. One is this and this. This is called y equal 2x graph. This is called y equal 0. It's combined answer for what? Y equal x plus modulus x graph, right? This here drawn. Therefore, now you can draw any type of modular sketch, straight line using its modulus properties, right? So I hope you understood this. The next time I show some more other type of parabolic shapes, how to use the parabolic modulus and some more complicated straight line graph. So many questions there in my tutor, you can try those problems.